Hi, this is Chuck. In this particular video, we're going to take a look at some homework problems for using the method of undetermined coefficients. Four of them are going to be problems where we're going to look for a particular solution, and then the last one, we're going to look for a general solution, which is a somewhat expanded version of a particular solution. In the first problem here, we're looking at y double prime minus 3y prime minus 4y equals 4x squared. The first thing we want to do is to look at the function on the right-hand side. It is a polynomial. Now I've provided here a little table of suggested trial particular solutions. In our right-hand side, we have a quadratic. Aha, that's something like this, which essentially means that we're going to set up a scenario where we're going to let our particular solution be of the form ax squared plus bx plus c. Keep in mind that when we incorporate the y and the y prime, it may involve powers of x other than just x squared. So we need to account for all the possibilities. Okay, so this gives us a proposed particular solution. In order to substitute the values into our differential equation, we also need to compute the derivative of our particular solution, which is going to be 2ax plus b. And then we also need to compute the second derivative of our proposed particular solution, which is 2a. All right, at this point, all we need to do is to substitute in our second derivative into the equation, and we're going to have 2a. Then we have minus 3 times the first derivative, which is going to be 2ax plus b. Then we're going to have minus 4 times the particular solution that we've proposed, ax squared plus bx plus c, and this is going to be equal to this 4x squared. Now the thing to be mindful of is there's actually an x term here. It's 0 times x, and there's also a constant here, 0. Just because they aren't there written out doesn't mean that they don't exist. They're just both 0. Okay, that's going to come into play at a later point. All right, so the first thing we're going to do here is we're going to expand our equation. So we have a minus 6ax minus 3b distributing the minus 3. Now I'm going to distribute the minus 4, and we're going to get 4ax squared minus 4bx minus 4c equals the 4x squared. All I'm going to do now is to align the terms from the right-hand side that involve x squared and associate those with the terms on the left side of the equation that also involve x squared. So we're going to have is a minus 4ax squared is equal to 4x squared. I'm going to divide or cancel out the x squareds, which is then going to give me a minus 4a equals 4. This thing gives us that a is a negative 1. We also need to find values for b and c. These may actually be terms in our solution. Okay, so in order to go after that, let's next take a look at the terms that involve x. I'm going to go ahead and I'm going to cross out this 4x squared on the left side. It's just a bookkeeping way for me to make sure when I've finished everything up, I've got everything accounted for. On the left side, we have a minus 6ax minus 4bx. So let's see, I've accounted for this term and this term. And these are going to be equal to the right-hand side value of 0. Okay, so I can rewrite this as a minus 6a minus 4b equals 0. using a equal to -1, this is going to give me a -6 times the -1. And I'll go move that 4b to the other side, make it a positive. Okay. This is going to give us then that the 4b is equal to a +6, or b is equal to 3/2. The last thing I'm going to do is I'm going to consider the constants on each side. On the left side, we have a 2a, we have a -3b, and we have a -4c. So going back to the bookkeeping, the 2a's accounted for, the -3b's accounted for, the -4c's accounted for, and as I look across the left side of my equation, I've now accounted for each of the terms that are on the left side. This is going to be equal to 0. Now the good news is I already have values for a and b. So if I substitute in the -1 for the a value, I'm going to have 2 times the -1 minus 3 times the 3/2 minus 4c equals 0. So this is going to give me a -2 minus 9/2 minus 4c equals 0. I'm going to go ahead and move the 4c to the other side and combine these two, the -2 and the -9/2. That's really 4/2 and 9/2. That's going to be 13/2. And of course it'll be negative, equals 4c, which then allows us to compute that c is going to be equal to a -13/8, dividing both sides by 4. This now gives me values for a, b, and c. My a value is up here at the top of the screen, -1. The b value is 3/2, and the c value is a -13/8. I can put all this information together now, and my particular solution in this case, remember it was a times x squared, so that's going to be a -1 times x squared, plus bx, well that's 3/2 x, plus c, well that's going to be a -13/8. And there is the particular solution for this first problem. All right, let's move on to a second problem. And in the second problem, copy down. For the second problem, we have a y prime minus, or y double prime minus y prime. So we have a y double prime minus y prime. And we're going to have with that plus y is going to be equal to 2 times the sine of 3x. In this case, we have to be careful because we have not just a proposed solution, but we're going to need the derivative of it. And remember, the derivative of sine is cosine. Aha. So when we choose a possible solution, we're going to need to involve not only sine in our solution, but cosine as well. So I'm going to come up here, and let's see, here we go. We've got something like sine, except in our case, we have sine of 3x and not 4x. So this is going to be a cosine 3x plus b sine 3x that we're going to use for our proposed solution. So it's going to wind up being the case here. Our proposed solution is going to be a times the cosine of 3x plus b times the sine of the 3x. Okay, before we can start substituting values into the original equation, I need to compute the derivative. Well, the derivative of this is going to be, well, let's see, the derivative of cosine is going to be a negative, and it's going to be the sine of 3x. Using the chain rule, the derivative of the 3x is going to give us a 3. For the second part, I'm going to have plus, then I'm going to have a b. The derivative of sine is cosine, and we're going to get our 3x. Then using the chain rule, we're going to have a 3 times that b. And the last thing we're going to wind up with then is our second derivative of our particular solution, which means I'm going to take the derivative of that one. Okay, so I'm going to have a negative, and I'm going to have the a times the derivative of sine is cosine of 3x. And notice I'm going to have a 3 coming out from that times the 3 that's already over here in the coefficients. That's going to give us a negative 9. For the second one, I'm looking ahead. I'm going to be taking the derivative of cosine. That's going to be a negative. I'm going to have my b. I'm going to have the sine of 3x. And just like before, I'm going to have a 3 from the derivative of 3x times a 3 on the coefficient. There's the 9. All right, so substituting these into the equation that we started with, we're going to wind up with, for the y prime, a minus 9a cosine of 3x minus 9b sine of 3x. Then, for the y prime, be careful, we got to subtract. So as I introduce each of the terms from the derivative, I'm going to also apply a negative. So this is going to become plus 3a sine of 3x minus 3b cosine of 3x. And then the very last thing I'm going to have here is get rid of that volume, is just the function itself, the proposed function, which is going to be plus a cosine of 3x plus b times the sine of 3x. And this is all supposed to add up to 2 times the sine of 3x. Okay, in the previous one, I sorted out my terms based on the power of x. In this case, I'm going to be looking at sine versus cosine. And the first thing I want to do is take a look and see, does any of this combine or does any of this subtract off? Notice all the cosines are going to be of 3x and all the sines are going to be of 3x. But I do need to be careful because the coefficients can be either a or b. All right, so first off, I have this minus 9a cosine. And I'm looking for a times cosine. Aha, here's an a times cosine. Okay, don't see any other a times cosines in there. So I'm going to combine those two, and I have a minus 9a plus a. So we have a minus 8a cosine of 3x. All right, next thing I'm going to look around here for is b times cosine. And it seems there's just one of those. This term here is a b times cosine, so that's going to be a minus 3b times the cosine of 3x. So that has that taken care of. The next thing I'm going to be looking for is a times the sine of 3x. Well, here's a 3a sine of 3x, and I'm not seeing any other a times the sine of 3x. So this is going to be plus 3a sine of 3x. And the last thing I'm going to be looking for here is b times the sine. Well, here's a negative 9 of them. Plus 1 of them is going to give us a negative 8 times b sine of 3x is equal to 2 times the sine of 3x. Now, the thing to be mindful of is on the right-hand side, there is also a cosine term there. But it's really going to wind up being 0 times the cosine of 3x. Okay, it's there, but we don't bother writing it down. But when it comes time to start looking at our values for a and b, I need to include that. Because what I'm going to wind up with here is a negative 8a cosine of 3x minus 3b cosine of 3x equals 0 times cosine of 3x. Okay, so let's see. I've got that term accounted for and that one accounted for. Very important to make sure that you don't overlook any terms. The next thing I'm going to do is I'm going to create a second equation, and it's going to involve all the sine of 3x. Well, I have 3a sine of 3x minus 8b sine of 3x equals 2 times the sine of 3x, which gives me two equations now to work with. Okay, first thing I want to do is check all my signs, make sure that they're correct. Looks good. Now, I have a system of equations here. What I want to do is to multiply things so that one or the other of the terms, either the a or the b, is going to cancel out. I could go after the a because I'm seeing a positive a here or negative a here and a positive a here. So the signs will line up great to cancel out. I'll multiply this by 3, multiply this by 8. And what we now have then, when we add these two equations together, is a minus 24a plus 24a gives us a 0. That's good news. We have a minus 3 times this. There's a minus 9. And then, oh, the 8 times 8 is going to be 64. So this is going to be a minus 73b equals. Now, I'm going to take the 3 times the 0 is 0. The 8 times the 2 is 16. Aha. This gives us then that b is equal to a negative 16 over 73. Remember, there's nothing that says that the coefficients need to be nice, clean numbers. They can be whatever they turn out to be. All right, to solve for a, all I need to do is to substitute b into one of these two. I'm going to take the second equation. So I'm going to have 3a minus 8 times a negative 16 over 73 equals 2. Okay, so what this is going to wind up giving me here is a 3a, and the minus times the minus is going to be a plus, and I'm going to have then the 16 times the 8, which is going to give me 128 over this 73 equals 2. Okay, so the 2 times the 73 is going to give us 146. And from that, I'm going to subtract the 128 over 73 because remember, I'm going to be moving this over. And this is going to give me that 3a is equal to 18 over 73. Dividing both sides by 3, I get a is equal to 6 over 73. Now that I have a value for both a and b, I just need to figure out where's the a and the b go. Coming all the way back up to the proposed particular solution, and that proposed particular solution is right here. So the a goes with the cosine term, and the b is going to go with the sine term, which allows me to write my particular solution as 6 over 73 times the cosine of 3x minus 16 over 73 times the sine of this 3x. So that gives us all of that. Make sure that everything's looking good. There's the second one done. Good deal. There. All right, on to a third problem. In this third problem, you're given the y double prime plus 4y prime minus 2y is going to be equal to 2x squared minus 3x. And then it's going to be plus 6. This one is going to work very similar to the very first one that we did. We're going to use the same proposed or trial particular solution that we did earlier. We're going to let our y of p equal to ax squared plus the bx plus the c. And if you want, go ahead and pause this video and work this one out. See if you can work this out on your own. If you get stuck or when you get finished, go ahead and play the video. Or if you're finished with it, fast forward on the timeline to where the solution is for this and see how this worked for you. Hopefully you actually paused the video and you computed that the derivative is going to be 2ax plus b. And the second derivative of our particular solution is going to be 2a. We're going to take these values, substitute them into our original equation. So we have our y double prime is 2a. Plus, now we have 4 times the derivative. So that's going to give us plus 8ax plus 32. Remember, we're distributing the 4, so each of those terms is going to be times 4. And then the last thing we're going to do is we're going to substitute the ax squared plus bx plus c into y, which means we're going to need to multiply by 2. So we have a minus 2ax squared minus 2bx minus 2c equals, we have our 2x squared minus 3x plus 6. All right, we're going to match up our x squared terms. On the right-hand side, it looks like I have a minus 2a equals, and on the left-hand side, the x squared term is just 2. Okay, so I'm going to mark that I've got this accounted for and that accounted for. This then gives me that a is a negative 1. For the x terms, well, let's see here. We have an 8ax minus 2bx equals, and on the right-hand side, we have a negative 3x. So I'm going to underline these, the 8ax, the minus 2bx, the minus 3cx. This is then going to give us that 8a minus 2b is a negative 3. We can substitute the value for a in there, and this is going to give us then a negative 8 minus 2b is a negative 3. Add 8 to each side, so we have negative 2b is equal to 5, or b is a negative 5/2. I'll put a box around these so it's a little easier to find them when we get to the point where we need them all. Next, I'm going to move to the x to the 0 power, or the constants, and see what constants we have in our equation. Well, we have a 2a, we have a minus 2c, and we have a plus 6. Oh, look, hey, we also have this 32 here. Where'd that 32 come from? Let's see here. That came from, well, that 32 came from a mistake. What I was doing is I was multiplying the 4 times the derivative, and I took the 4 times the 2a to get the 8ax, but then I took the 4 times, I read this as being an 8. It should really be a 4b. There's a problem with that. No, there isn't. It's okay. It was a constant, so it hasn't entered into things. So that's good news. So we also then have this 4b as part of our solution for the equation where we're just working with the constants. Our constants are going to be 2a plus 4b minus 2c, and those should add up to give us 6. The nice thing is we already know a value for a and a value for b. So I'm going to substitute in the value for a, which is a negative 1, 4 times the value for b, which is a negative 5/2, minus 2c equals 6. All right, when you take and you work through all the arithmetic on this, the left-hand side winds up giving us a minus 12. So we're going to have to add 12 to each side, so it's going to give us a minus 2c equals 18, where c is equal to, looks like c is going to be a negative 9 in this case. Okay, that then gives us our final solution, our particular solution, y prime, is going to be our a value times the x squared term, so that's going to be a negative x squared. Our b value is going to go negative 5 halves times the x, and then our c value is going to wind up being the minus 9. So there's our particular solution for this third problem. All right, so with that one under the belt, let's move on to a fourth one. In this fourth problem, let's take a look at something like y prime plus 2y prime, y double prime plus 2y prime plus y, like that, is equal to x times e to the 2x. This one's going to get a little longer, a little messier, but it's the same process. Okay, don't let the extra terms distract you or lead you down a wrong path. Okay, so what we're going to first do here is we're going to take a look at what is an appropriate trial to run for our proposed solution here. We have x e to the 2x. Well, I'm going to make reference back to way up here. And let's see if we have anything up here that's going to work for us. Well, as I'm looking for an x e to the 2x, or some form of x times e to something or other x, and I'm not exactly seeing anything right there. The one that comes closest to it is this one right here. But notice this also has a cosine and a sine. Okay, so I really don't need the cosine. I really don't need the sine. And the way we can actually look at this, okay, is the following. We don't have one on there exactly matches this. This is really a form where we have a polynomial times an exponent. Now, what we can do is we can rewrite our particular solution as the polynomial. Now be careful. This is ax plus b. This can really be looked at as x times e to the 2x plus 0 times e to the 2x. Factoring out the e to the 2x, we have x plus 0. Aha! We do have a polynomial with both the variable x to the first degree plus our constant. Now what we want to do is multiply by e to the 2x. And if you're thinking, well, I'm not quite sure how that works, that's fine. You can come take a look at that. And that's like this one right here. Notice there is a coefficient in front of the e to the 5x, which means that when we look at this, we're going to have a coefficient times e to the 2x, like that. We can distribute this if we want, okay, or just leave it the same, whichever you want to do. The question comes in, which is the easier way to take the derivative? All right, so how do we wind up taking the derivative of this? It depends. If you want to distribute the c e to the 2x, you could really just have this as a times x e to the 2x plus b e to the 2x, where a and b and c are arbitrary constants, and we could view a times c as just a, and b times c is just b. If we're going to set it up like this, using this for our particular solution, what we're going to wind up needing to do is to compute the derivatives. So the first derivative is going to require a product rule. So we're going to have a e to the 2x plus, I'm going to save some space, we're going to have our ax. The derivative of e to the 2x is e to the 2x times the derivative of 2x is 2. So that has that. Plus, the derivative of our second term is going to be 2b e to the 2x like that. All right. Now, we next need to compute the second derivative. We have our original function, or our proposed solution. We have our first derivative, and what we now need to do is to use the first derivative to compute a second derivative. So our second derivative here is going to be 2a e to the 2x plus, now this middle term here is a product. So we're going to need to use the product rule. We're going to get 2a times the derivative of x is 1, e to the 2x, plus, now we're going to take the first, which is the ax, times the derivative of the second, which is going to be the e to the 2x. Chain rule time, derivative of the inside is 2. Then we're going to multiply by that 2, which is going to give us 4. Plus, derivative of the third one, we're going to wind up with just 4b e to the 2x. Remember, when you take the derivative of this, you multiply it by whatever the coefficient was, and that was a 2 originally. Okay, so now what we can do is we can start substituting in our derivative, our second derivative, and our trial solution into our original equation. We have y double prime, so that's going to give us a 2a e to the 2x plus 2a e to the 2x. Hey, have we seen that somewhere before? I think so. We can add those two together and just make this 4a e to the 2x. And that has this term and this term taken care of. Now I'm going to have plus 4ax e to the 2x plus my b, and that's going to be times 4, e to the 2x. So there's my y double prime. When I substitute in my y prime, notice it has a coefficient of 2 on the y prime, so I'm just going to need to multiply the y prime by 2. So that's going to give me plus 2a e to the 2x plus 4ax e to the 2x plus 4b e to the 2x. So there's that term. Then I need to do the y, and the y is just going to be ax e to the 2x plus b e to the 2x. And I'm running out of space here, but it's going to be equal to, and if you look all the way up at the top, this is going to be x e to the 2x. Okay, so we've got a bit of sorting out to do here. What we're going to do with this equation, I'm first going to sort out my x e to the 2x terms. And as I sort through here, the x e to the 2x terms are going to be this one. Let's see, we have an x e to the 2x there, and we have an x e to the 2x there, and I think that's about it. So it gives us 4 plus 1, which gives us 9x e to the 2x equals, sorry, it's 9ax, which is going to be equal to x e to the 2x. We can cancel out the x e to the 2x from each side, which is going to then give us 9a equals, be careful, it's not 0, it's 1, which is going to give us a is equal to 1/9. Okay. Now, what else do we have laying around here? we have some e to the 2x terms. In fact, we have quite a few of them. Starting at the far left, we have an e to the 2x term equation coming up here. We have 4a. Now on each of these, I'm going to go ahead and leave out the e to the 2x, or if you would, divide by e to the 2x. E to the 2x is never 0, so it's fine to just go ahead and divide by that. So from this first term, factoring out the e to the 2x, I'm left with 4a. From the second term, right here, left with plus 4b. Okay, so that's got that one taken care of. Now, we have here 2a e to the 2x, so I'll put a line under that. That's now accounted for. The next one's over here to the right, a 4b e to the 2x. And then way over to the right-hand side, almost off of the screen, we have a b e to the 2x, which is just going to be plus b. On the right-hand side, we do not have a constant times e to the 2x. Well, that means that on the right-hand side, what we really have is 0 e to the 2x. Aha! So I need to solve this equation equal to 0 after I combine my like terms. So I'm going to have 6a plus 9b, equals 0. Okay, so what's a equal to? Well, a is the 1/9 that we just solved for up here toward the right-hand side of the screen. And we can substitute that in, and it's going to give us 6 times 1/9 plus 9 times b equals 0. Well, the 6/9 is 2/3. So this is going to give us 9b is a negative 2/3, which then gives us, looks like b is going to be a negative 2/27. Okay, so we go back to our original proposed equation. Here it is in the upper right portion of the screen. It's a times x e to the 2x plus b e to the 2x. So our particular solution in this case looks like it's going to sort out to be our a value, 1/9 x e to the 2x, plus our b value, which is a negative 2/27, e to the 2x. If you look on some solutions, you'll find the 1/9 is factored out here, and you get 1/9 times x e to the 2x minus 2/3. Remember, if you factor a 9 out of 27, you're still left with a 3 e to the 2x. Which is right? Either. Either will work fine. So there's number 4 done. All right, now we're going to move into a slightly different direction. Instead of solving for a particular solution, we're going to solve for a general solution. In the case of a general solution, we need to also take into consideration what would work if we were solving the homogeneous case for our equation. Let's take a look at something that we can take a run at with that. Let's say we have the second derivative of y minus 2y prime minus 3y equals, and then on the right-hand side, let's have something like 2x minus 4. And to make it a little more interesting, we'll throw in plus 5x e raised to the 2x. Okay, so when we go for a general solution, the first thing we need to do is we solve the homogeneous situation. Recall, the homogeneous means that we're going to solve our second derivative minus 2 times the first derivative minus 3 times y equal to 0. This takes us back to our characteristic equations. This is a pretty straightforward one to solve. We're going to have r squared minus 2r minus 3 equals 0. This factors very nicely into r minus 3 times, we have an r plus 1 equals 0. Our roots are -1 and 3. So this gives us then what's called the complementary solution. If we were just solving the homogeneous case, we would have C1 e to the negative x plus C2 e to the 3x. We're going to hold on to that. I'm going to put a yellow box around that because I'm going to want to come back and find that later. This is solving the homogeneous equation. Okay, so now what we're going to do is we're going to go for a particular solution. And in this case, we're going to solve it as the non-homogeneous equation. And in working with the particular solution, we now have our equation y double prime minus 2y prime minus 3y is going to be equal to, we're going to have our 2x minus 4 plus 5x e to the 2x. Okay, so there's a whole lot going on here. What I first want to notice is on the right-hand side, I have a polynomial and an exponential being added together. We can use the principle of superposition to allow us to break this up into two separate particular solutions, solve each of them individually, and then come back to the total solution being the two parts put together. So what I'm going to do is I'm going to say, you know what, this is going to be part of my particular solution. This is going to be another part of my particular solution. I'll solve them individually and then in the end bring it back together. And in the end, my particular solution is going to be, because these two are added together, the product of the two particular solutions. Okay, so what this means is I'm going to have two things going on. First, I'm going to solve the second derivative minus 2y prime minus 3y equals this 2x minus 4. In this particular case, I'm going to let my y sub p1 equal to ax plus b. So I'm going to match up my guess or my trial solution to be of the same degree and form, it's a polynomial degree 1, as the right-hand side for this part of the equation. All right, so with that in place, I can now compute my derivative. Whoops. And my derivative for this one is just going to be a, and the second derivative is not going to take much space at all. That's going to be the derivative of a is 0. All right, I can now take my trial solution, the derivative of the trial solution, and the second derivative of the trial solution, substitute those into the equation. It's in the upper left-hand corner of the screen. Second derivative is 0, minus 2 times the first derivative is a, minus, now I'm going to do 3 times the derivative, or 3 times that, not the derivative of anything. But it's going to be a minus 3ax minus 3b, and this is going to be equal to 2x minus 4. At this point, I'm just going to match up my like terms. So for example, my x terms, terms that have a or variable of x in them, on the left side, I have a minus 3a times x equals, and then on the left side, I have 2 times x, such as 2. This gives me then that a is equal to a negative 2/3. For the constants, on the left side, I have this negative 2a minus 3b equals a negative 4. I'm going to multiply that through by a negative and make everything positive. It's a little bit easier to deal with. The second thing I'm going to do then is I'm going to substitute in my value for a here. And if I take 2 times this negative 2/3, it's going to be a negative 4/3 plus 3b equals 4. So I'm going to wind up adding 4/3 to this. And with this is, let's see, make sure I've got everything in good order here. Okay, so this looks fine. And what I'm going to do is I'm going to add 4/3 to each side, which is going to give me then that 3 times b is equal to, here I'm going to have 12/3 plus 4/3 is going to give 16/3, where b is equal to 16/9. All right, so this has allowed me to then compute part of my particular solution. Okay, so what's going to happen is that my y of p1 is going to be my a value, so it's going to be a negative 2/3 x plus 16/9. So there is part of my particular solution. Now, I'm going to come back up here and I'm going to do the second part of this. The second part of this is going to be the second derivative minus 2y prime minus 3y equals, I've already attended to the 2x minus 4. I'm now going to do my 5x e to the 2x. In this case, my y sub p, actually y sub p2, is going to look like, let's see, cx e to the 2x plus d e to the 2x. So there's my guess at a trial solution with this non-homogeneous equation. When I take the derivative, I have this, and I'm going to have c e to the 2x plus 2cx e to the 2x plus 2d e to the 2x. So there's my first derivative. The second derivative of this is going to wind up looking something like this. And we have 2c e to the 2x plus 2c e to the 2x. This first one comes from here. This second term is the first part of the product rule on that second term. And then we're going to have a 4cx e to the 2x. And then we're going to have plus 4d e to the 2x. Now, just in case you're wondering, where do these 4's come from anyway? What winds up happening is, I'll do this right-hand example here. I have a 2 as a coefficient. I'm going to get back the d, the e to the 2x as the derivative. The chain rule on this e to the 2x is going to produce a coefficient of 2 that will multiply by that 2 and give 4. All right, so now I have my function, my first derivative, and my second derivative. I'm going to substitute all of these into the original function way up there at the top. Starting with the second derivative, I'm going to have this 2c e to the 2x plus 2c e to the 2x, okay, which is going to give me 4c e to the 2x plus 4cx e to the 2x plus 4d e to the 2x. Then, looking back up at the top of the screen, notice that y prime is times a negative 2. So when I substitute this equation in, I'm going to need to multiply each term by a -2. What this will give me then is a minus 2c e to the 2x minus 4cx e to the 2x minus 4d e to the 2x. And I'm running out of space here, so I have to do a second line. Going back up to the top of the screen, I have a minus 3 times my original proposed solution. So that's going to be a minus 3 cx e to the 2x. Then I'm going to have a minus 3 d e to the 2x. And this is all going to wind up equaling this 5x e to the 2x. Okay, so I'm going to put a dotted line across here to kind of break up my derivatives from the equation. Okay, so now I got to be kind of careful here. I want to combine like terms, and I don't want to miss anything, so I'm going to continue underlining stuff like I have in the past. It's a safe way to keep from missing anything. Okay, so the first thing I'm going to start out with here is that my 4c e to the 2x. Notice it has a c, but it does not have an x times the c. So I have 4 of them. Here's minus 2 of them, and that's it. So the 4 of them minus the 2 of them is going to give 2c e to the 2x. The next thing I'm going to go after is the c times x terms. Here's a 4c times x minus 4c times x, and then I have a minus 3c times x. 4 minus 4 is 0, minus 3 is going to be a minus 3c times x e to the 2x. All right, so that has that taken care of. Next up, I'm going to look at the d times e to the 2x. Well, there's 4 of them. And as I continue down, here's minus 4 of them. So 4 minus 4 is going to be 0 of those. Then I'm going to have a minus 3 of them. So I wind up with minus 3d e to the 2x. And it's still equal to this right-hand side value of 5x e to the 2x. Okay, so now what I'm going to start doing is matching up stuff on the left-hand side with right-hand stuff that is either x e to the 2x or just e to the 2x. Remember, on the right-hand side, we do have a term that's 0 e to the 2x, so that we can account for the coefficient of 0. What I'm first going to do is I'm going to do my x e to the x terms. And what that's going to give me is a minus 3c equals 5. Okay, on each side, I just factored out and omitted the x e to the 2x. This is going to give me then a c value equal to a negative 5/3. Now, I'm going to look at the terms that have just the e to the 2x, and that's going to be a 2c e to the 2x minus 3d e to the 2x equals 0 times e to the 2x. Well, the good news here is I already know what c is, so that's going to make it a little bit easier to compute d. When I substitute in, I'm going to have 2 times a negative 5/3 minus 3d equals 0. This is going to give me a negative 10/3. Move it to the other side, I get 10/3 equals a negative 3d. This then, dividing by a negative 3, gives me a negative 10/9. Okay, so what does this give me then? Well, I have a C value of negative 5/3, a D value, here let me rewrite this, a D value of a negative 10/9. And I know what my A and my B are. They're in the upper right corner or upper left corner of the screen. This gives me my second particular solution, and I'm going to go back up to the top to make sure that I get things in the right place. There it is. It's at the top of the screen. It's going to be C times X e to the 2x. So that's going to be a negative 5/3 x e to the 2x plus D, well, it's going to be a minus 10/9 e to the 2x. Now, if you'll recall, we said earlier, using the principle of superposition, our overall particular solution is going to be the one plus the second one. So what this is going to be is, I come back up here, and I'm going to have a negative 2/3 x plus 16/9. That's the y of P1 part. To that, I'm going to add a negative. Well, if I add a negative, it's just subtracting 5/3 x e to the 2x minus 10/9 e to the 2x. Here, then, is a particular solution. Let's move this up a little bit so I can write it better. So we have this as a particular solution. And the general solution is going to involve the solution that we obtained for the homogeneous equation. And that was C1. So I'm just going to put my y equals C1 e to the negative x plus C2 e to the 3x. Now the general solution includes not only the solution to the homogeneous, but also the solution, the particular solution to the non-homogeneous. So all of this stuff here is going to come along as well. And I'm going to have a minus 2/3 x plus 16/9 minus 5/3 x e to the 2x minus 10/9 e to the 2x. And there it is. That's kind of a long answer. It's probably not anything that you would have just off the cuff have guessed. You can clean this up a little bit, factoring out like a 5/3 from the second two terms and factor out e to the 2x. So you could factor out a negative 5/3 e to the 2x from these, and you could factor out a negative 2/3 from these. But really, then that creates parentheses and things, and it's not in as simple of a form, or as simplified of a form. So there you go. You have a particular solution listed right there, and you have the accompanying general solution.